Hi everyone, happy Janmashtami everyone. So, how are you all? Everyone in the chat box, welcome to Vedantu JEE English. I'm Diksha Ma'am, your chemistry master teacher, and happy Independence Day, happy Janmashtami to everyone out there. And I really pray to God that this year you get into your dream college, right? And all the blessings and to you. I really wish that your dream come true. Right? Okay. So, yes, everybody, tell me if I am clearly visible and audible to you because today is the last lecture of structure of atom. And pardon for my voice. I am trying my best to speak as energetic as possible. But as you all know, I was not well from the past 15 days. So that's why I'm still on the recovery phase and I find it little tough to speak. Right? Okay? Yes, everyone, but still I am here. I'm not leaving you and I'm still here for you. Right? Okay. So, guys, do let me know in the comment section. Are you ready for the class? And this is going to be a very interesting class because in this class, we are going to do the topic like radial wave function. Radial wave function. We are going to discuss three kind of graphs based upon it, and they ask you questions even in mains, right? Then we are going to talk about electronic configuration. That is actually a simple topic. It will not take that much of time, right? Okay. So everyone, yes ma'am, clear your voice. Very good, very good. So shall we start? Everybody spam the chat box with green hearts and fire emojis, right? So that the enthusiasm, the energy of this session we can increase. And I don't want you guys to be like, this topic, man. No, I want you guys to be happy on this topic that okay, we are learning something new, don't make this a boring topic, right? So I want this class to be engaging. For that, I need your help as well, right? Okay, yes. So, guys, before moving forward, right, one very important thing for all of you is that, wait a minute, that there is MV SAT. Wait a minute, I'll just show you this over here, right? There is this MB SAT scholarship program that is going on. Let me just show you that, right? MB SAT scholarship program is right now going on. You can see this over here. In the description box, you will see this, right? So basically, what all you're going to get in MB SAT scholarship program, first is registration is completely free of cost. You can get complete nationally and get AIR with detailed performance report, right? You will have to compete with other students, right? And based on your AIR, what you are going to get? 2 crore, including laptop, phones, and drones, right? So it is entirely based on your test. What is the marks that you will get here? Then 100% scholarship on our Vedantu courses. 100% off. Like you don't have to pay even a single penny, right? Then you will get free courses and other learning material as well, right? So all these things will be, what you have to do is you just have to register yourself here, right? Once you register yourself, after that you can choose two things. You can go for an online test or you can go for an offline test. I would advise you offline test if you have Vedantu center nearby. Okay, yes, very good. Now let us start with the topic. I don't know why today things are not getting synchronized, but it's okay, I think, right? Okay, yes. So let's start. Guys, in the last lecture, I told you about nodes and antinodes, right? So we discussed that this wave function is actually based on three parameters. One is radial wave function, right? Then these two are angular wave function. Angular wave function. Now, if you talk about radial wave function, right, if you have the point here, from this particular point, what is the distance, right, of the electron from the nucleus, right? It is defining as the radius, right? It is based on the radius from the nucleus. What is the radius? That is defined as radial wave function, right? So it is based on the radius. If this is the center, you will move in radius, and that will be defined as radial wave function, right? As I'm showing you this, it is moving here in this direction, in this direction, in this direction, this direction. These all are radial wave functions, right? Angular wave function is not like that. Angular wave function is actually the angle that you will be making here, right? So what is the angle that you will be making? This line from origin to this R point, the line that it is making, the angle that it is making with z axis, that is called theta, right? Angle with z axis is called as theta, right? Maximum they can ask you for this is they can ask you the definitions of theta and phi, right? Phi is when you draw the shadow of this particular line. I'm drawing the shadow of this particular line. Then this line, what angle it makes with the x-axis? This is with x-axis, this is with z-axis. Angle of shadow with x-axis, that is called as phi. Okay, that is called as phi. Okay, so this is about theta and phi. Ma'am, what things they can ask you based on this? Just the definition part you have to know. Okay, that theta is which angle and phi is which angle. Because when we solve the, I showed you Schrödinger wave equation. When we solve the Schrödinger wave equation, then we make use of these things. But as of now, it is not important for you, right? As of now, it is not at all important for you. Okay, guys, right? Good, everybody. Now, let's see. I told you about the formulas, right? So, number of radial node is n minus L minus 1. Angular node is equals to L. And number of nodes in an orbital, that is equals to n minus 1. So, I also showed you what are angular nodes and what are, wait a minute, let me just take one example. See, if I talk about radial node, it will be along the radius. Along the radius, there is a point, that is this particular area, where no electron we can find, right? That is radial node because it is along the radius, right? But now, if I talk about this thing, it's from this one, this is the best example to visualize the radial nodes and angular nodes. Best example. Okay. So if you see this here, if I want to visualize the angular nodes, guys, angular nodes, I told you, this is actually plane passing, right? If you have to visualize the angular node, let's say this is a sphere, right? Okay, let me just draw any random structure here, right? Any random structure here, let me just see. Okay, right? This is like radial node, right? Across the radius, you have a thing where it is having no electrons, right? So that is your radial node. Angular node is, for example, you have a situation like this. Wait a minute, I'll just show you a structure which will seem the same. Okay. Okay. Can you see this over here? Everyone, can you see this? Oh, it's okay, Abhijit. It's okay, Abhijit. Yes, all the best for your exam, right? So, can you see this here? Right? It's like If I see this is the center point, then from the center point here you can find this blue is mentioning you the electrons that you can find. This is the area where electrons cannot be found. Only in this blue region you can find the electrons, right? If I want to see whether this empty space is radial node or angular node, how I will see that? If I from this point, if I mark this point here, if I move here, you will find electron. If I move here, you will not find electron. Move here, you will not find electron. That means it's not like along a single line or along a radius you are not finding any electron. See, if you see a spherical node, okay, if you see a spherical node, this is along the same pattern, along the same radius, no electron you can find. But if you see a dumbbell shape like this, right? If you see a dumbbell shape like this, it's actually like this. It's actually like this. Okay, it's actually like this. So in this case, it means that I can pass a plane here, right? Let's say my hand is a plane, right? So when you can pass a plane, when on the plane, on this plane, you have no electron. On this hand, you can't see any electron. Electron are above it, electron are below it. That means then you have missing electrons along the radius, that is radial node in visualization. And when you can pass a plane, right, which is having no electrons, that is called angular nodes, right? If you see this here, right, see how beautifully it is defined here, that this particular area where you can't find anything, it is actually a plane, right? It is actually a angular node, right? But if you see this particular area or this particular area, this is actually along the radius. From the center along this circular radius, you can't find any electrons. So these two are your radial nodes. Students, tell me if now it is clear in your head how to draw angular nodes and radial nodes. Similarly, here this is the radial node, these are the angular nodes. Here this is the radial node and this area is the, sorry, this is the angular node and this area is the radial node. This area is the angular node, this area and this area is the radial node. Similarly here, this is angular, this and this area are the radial nodes, right? Okay, it's better. But obviously, doctor has advised me not to, talk too much. So that's why I'm taking small classes. Okay. Oh God, what to do with my hair? Wait a minute. But tell me if that is clear to everybody or not. Right? Okay, everyone. Okay. Right? Beta, at least speak something, no? At least say something, beta. Okay. So now what I'll work towards, I'll start making the graphs now. Okay. So for graphs, you have to be even more attentive here, right? So one by one, we will study that. First kind of graph is, that is radial wave function, right? That is this radial wave function, right? And this is your angular wave function. This is your theta and phi is angular wave function. So we are not going to draw graphs of angular wave function. We will only focus on radial wave function. So now let's see, if I only focus on radial wave function, then what I'll have. If I only focus on radial wave function, there will be three kind of graphs. One will be the graph of this with the radial. This graph we are not going to draw. Angular wave function is not in your syllabus, right? Then we are going to draw the graph of psi square, and that to radial psi square, right? With respect to r. Then last graph and the third graph that we are going to draw is for radial distribution. That means 4 pi r square dr psi square versus r. This is psi square versus r, right? And this is psi versus r. So we have three category of graphs that we are going to draw. One is psi, other is psi square, other is 4 pi dr psi. Okay, this is called radial wave function. This is called radial probability because psi square is probability, and this is called radial probability function. Okay, radial probability function. So these are the three graphs that you will have. Now, one by one, I'm going to tell you the rules here. See, if you see the rules here, very simple funda for rules is, if you draw for now, this particular page is all you need to solve the questions of graphs. That's it. This page is enough, right? So let's see what is this page. Now, first is psi. In psi, what you have, it can be positive or negative both sides, right? Positive and negative both sides means it can be like this. Okay, it can be crest and trough, positive and negative. For psi graph, you will have both positive and negative. But for psi square and 4 pi r square psi square, r square dr psi square. For this particular thing, you will have always positive. That means it will always lie on the positive side. It will never lie on the negative side, right? Next is for s orbital. Now this was about whether it's on the positive side or negative side, right? Positive or negative. This is for whether it will start from maxima or minima. Means graph can start from here or graph can also start from the origin, right? So we are defining it by maxima or minima. This is defined as maxima and this is defined as minima. Now, what is the rule? Which will be maxima, which will be minima? Okay. So for s orbital, always it doesn't matter. So what you will see for s orbital, psi and psi square will always start from maxima. It will always have this kind of graph. But if you talk about 4 pi r square dr psi square, it will start from the minima. That means it will start from the origin, right? P orbital or D orbital, you can also write here D orbital, P or D, right? Whatsoever you have, you will always start it from the minima. It doesn't matter, it's psi square, it's 4 pi r square dr psi square, it doesn't matter. It will always and always start from the minima. Okay, yes, everybody. Start to solve the Schrödinger wave equation. Firstly, you will have to complete your 12th class, then you will have to take admission in BSc. Only then. Hai na? So, these things are not in your syllabus, not even JEE Advanced, right? That is another thing in itself. Solving the Schrödinger wave equation is another thing in itself, right? Okay. Now, then there is, will the peak decrease like this? Peaks are decreasing or the peaks will increase, right? That is the next question. So psi and psi square, peaks are always going to decrease and 4 pi r square dr psi square peaks are always and always going to increase, right? Okay, yes. Obviously, beta, in Sigma batch, we provide you like proper things that are needed, right? It's just a trailer. YouTube is just a trailer of Sigma batch. Okay? So, understood everybody? Now, one by one, I'm going to draw three graphs and let's see who will answer this, right? One by one, I'll draw three graphs and I'll see who will answer this, right? It's a very interesting concept if you actually study with interest. But if you don't study it with interest, then it is not going to be interesting, right? So one graph is between psi and r, right? Another graph is between psi square and r. Then third graph is between 4 pi r square dr psi square and r. Okay. Now, what they have given us, we are talking about 1s orbital. 1s orbital, guys, n is equals to 1. N is this number here. What is s? For s, L is equals to 0 is s. It's like that. 0, 1, 2, 3, S, P, D, F. So when L is S, that means L will be equals to 0, right? So you can write here L is equals to 0, and here radial node, because guys, can you see we are always solving for radius. So we need to check the radial nodes. We have nothing to do with angular nodes. We are not calculating that, right? So it is n minus L minus 1, that is 1 minus 0 minus 1. Can you see? No radial node here, right? No radial node, and that is the reason here what you will have for psi, a graph is both positive and negative, and the graph starts from minima or maxima. I showed you the rules here. For psi, right, when you have psi, it is both positive and negative, right? Then for s orbital, psi and psi square will start from maxima, this will start from minima. And in first two graphs, it will decrease and then it will increase, right? So can I just write here, then it will start from maxima and this, right? It will start from maxima and this. It will start from minima and this. Now you will say, ma'am, how can you say there is no radial node involved here? See this. If you actually see the diagram of s orbital, this is 1s orbital, right? If you see the diagram of 1s orbital, can you see there is no radial node? From the equation also we solved that there is no radial node, right? Now, can you see radial node means it's not like there is no point where you can't find the electron. Yes, here you can't find the electron in all these points. But node is that thing where you will see, firstly, it will decrease the number of the probability of finding electron will become 0, then again it will increase. If again it is not increasing, if here it is increasing again, then I would have said that this is node, right? So guys, the main thing is that if I want to consider this as a node, then I need to have electrons here. I need to have another time, another radius where the electrons will start again, right? And here it will be electrons, then it will stop, there will be no electrons, then again you will see some electrons. That is defined as radial node. So here we know that you can't see any electrons after this, right? That means this is not the node. This is the end point, right? So end point minima is never considered as node. This end point where psi is 0, that is never considered as node. This is never considered as node. This is never considered as, okay? Clear everybody? Right? Very good, future IITian, very good. Next is for 2s, right? I'll do the same thing. Students, everybody tell me what is the, trust me, no? After this class, you will never find this difficult. You will be like, ma'am, this is super easy. Right? That I can assure you. You will find it super, super easy, and there will not be any question that you won't be able to do from this. And very simple questions they ask. They don't ask you very complicated questions. Okay? Right? So, if you see 2s, n is equals to 2, L is equals to 0. So radial nodes is equals to n minus L minus 1. N is 2 minus 0 minus 1, and that is equals to 1. Okay. N minus L minus 1, that is 1. Now we have one radial node. Now, if I say that, ma'am, we have one radial node, now who will tell me this? This is psi and r. This is psi square and r. Third graph is between 4 pi r square dr psi square. Okay? And r. One radial node. That means here it will start from maxima, it will decrease, then it will go on the negative side. And always, no, first two graphs, if you see this here, first two graphs peaks always decreases, then third is increases, right? So what you will draw here, when you're drawing this, what you will do here, here peak will be more, then it will decrease here, and it will be like this, right? Here peak is more, here peak is less, right? Now, if you draw the same graph for this one, it will start from maxima, then point to 0, then it will again rise, but peak decreases. So it will be 0 and it will decrease. Can you see that? From the simple rules, I am drawing that. I have not crammed these graphs, right? I am telling you just by rules, right? You don't need to cram it, right? 4 pi r square. Guys, third. What was the third? Third graph will always peaks will increase here, right? And for s orbital, third graph starts from minima, right? So can I say minima and peaks will increase here, right? Can I draw minima and peaks will increase here? Okay, guys, sure. Now, it is starting from minima. Peaks are increasing here. So it will start from this, and this is your graph for 2s, right? For 2s, for 4 pi r square dr psi square. And now you will say, ma'am, how do you identify the radial nodes here? I told you starting and ending. It's like it's like, okay, one thing. You are going from your home to your tuition or school, right? Or maybe to eat something in the market you are going. There will be one point where your speed will be in the initial phase, that is 0. And this will be the final phase where your speed will be again 0. I am not saying that this is where you have stopped. No, I am not saying this is where you have stopped. We want to find out the places where you have applied the brake and you stand for about 1 to 2 minutes. Maybe somewhere here, maybe somewhere here, maybe somewhere here. These are the nodes. These are where your speed was 0. Speed was 0 here also and here also, but we don't consider it as stoppage. You're going from Bangalore to, let's say, Ooty. Okay, you started from Bangalore and you ended it to Ooty. Now it's like in between you will have some stoppages. This is what we call nodes. Bangalore and Ooty is not your stoppages, right? That is initial and final. Same thing. Initially, if it is starting from maxima, that's great. Final, we will never consider. This will be considered as. This is already maxima. This is never considered as node. This is your node. Here, only this is node. Starting and final point is never node. Okay. Starting and final point is never node. Okay. Okay. Yes. Right. No, I have not drawn two radial nodes. This is not a node. That's what I'm telling you. This is not a node. Only this is a node. starting and the final points are never the nodes, right? Okay, understood? Tell me if that is clear so that I should move with the next part. And how do you draw this? How do you draw this radial node? This is your radial node. This is your radial node by visualization, right? Okay. And when you see 1s and 2s, how they overlap with each other, this is how they overlap. There must be some nucleus here. This is 1s, and here you will have 2s also, that is overlapping here. And if you see 3s here, that will also overlap from the nucleus point. So this also is starting from nucleus, and this also is starting from nucleus. This also, if you see this here, this is also starting from nucleus. And when you visualize both the things together, this is how they will look like, right? Then for 3s, you can draw the similar way, right? 3s will have n minus L minus 1, that is 3 minus 0 minus 1. It will have two radial nodes that you can see this here. One will be, this will be the radial node. One is, this will be the radial node. Other is, this will be the radial node. So these two are going to be the radial nodes. Radial nodes. Okay. If you want me to draw the diagram for you guys, I can do that. Okay. If that makes you, like, ma'am, yes, now we know the topic more. So here nodes are two. So how do you draw it? Let's see that. How will you draw it? Let's see that. Two radial nodes you will have, right? Psi always starts from maxima. Yes, maxima. This always starts from maxima. This always starts from minima. Right? Now, I need to draw two radial nodes, and here peaks are decreasing. So I'll draw it here, then I'll draw it here, then I'll draw it here. Can you see 1, 2? Two radial nodes. Yes. Again here, 1, 2, 3. Can you see peaks are decreasing, and here you have two nodes. And here it will start from minima. Peaks are increasing here, okay? Peaks will increase here. 1, 2, and 3. Now we know that the initial and the final point is never the node. This is never node, not node, not node. This is node. This is node, right? This is node. This is node. Just give me a second. Yes? Understood? These two are nodes. This is node, this is node, these are not nodes. Initial and final points are never the nodes. Right? Okay, crystal clear? Very good. Now let's start with the next part, that is 2p. Now for 2p, how do you draw it? For 2p, I'll just draw one here. Okay, other graph here. Other graph, I can draw it over here. Okay. Now, let's see. Who will tell me how many radial nodes you have? Who will tell me the radial nodes for 2p? Radial nodes is, for 2p, n is equals to 2, L is equals to 1, right? Radial nodes are n minus L minus 1, that is 2 minus 1 minus 1, and that is nothing but 0, right? So radial nodes are 0. Can you draw angular nodes? Angular nodes, here is L, that is equals to 1. Ma'am, why you have not told us about angular nodes here? Because students, if you see this 2s here, for 2s, angular nodes will be equals to L, that is 0. Right? For 1s also, if you see, for 1s also, this will be equals to 0. So for 1s, 2s, angular nodes are always equals to 0. I can just write it here as well. Angular nodes are equal to L, that is 0. Right? Here as well we have written it. Okay. Angular nodes is equals to L, that is equals to 0. Right, so that's why we were not talking about any angular nodes here. Because angular node for s orbital is 0 only. Right? But for p orbital, it is not equals to 0. Let's see that here. Right? It is equals to 1. Now, when you want to draw a graph between psi and r, let's see and check out the rules here, right? Let's see and check out the rules. Now, guys, can you tell me from these rules, if I talk about p orbitals, right? It will always start from minima, doesn't matter what. P and D orbitals will always start from minima. It doesn't matter whatsoever it is, right? Then psi and psi square, that is same, peak decreases and then increases. This is the important point, okay? It will always and always start from the minima. Now, 0 radial nodes I have to draw, right? I am drawing this graph for radial nodes. That is in your syllabus. Right? So I'll draw 0 radial. Don't draw angular nodes here. This is the radial graph. So you have to draw the radial nodes. You don't have to draw the angular nodes. Right? So it will start from minima. It will increase and that's it. 0 nodes we want to have, right? So initial and final is never the node. So now here radial node is 0, right? Similarly here between psi square and r, this is 4 pi r square dr psi square and this is r, okay? Now from this and this, both it will start from minima, right? Very good. 0 radial node for 2p, very good. Now it will start from minima, right? Peaks will decrease, but do we need to draw any peak? No, it will 0, right? Peaks will not be there. Peaks, we don't need to draw any other peaks because radial node is 0. So it will be the same graph. Now, do you need to cram it? No. You just need to know the rules and that's it. The structure of 3p, let's see, structure of 3p orbital, it looks like this, right? We draw it like this in 2D, but in 3D, it looks like this, right? So that's why we define it like this, and then we define it like this, and then we join these two together, and that's how we draw a dumbbell shape, okay? If you see this here, as I have already shown you, there is no radial node and across the radius, the probability is not decreasing, but it's across the angular plane. So that's why this is angular node. You pass a plane like this and that plane will have 0 electrons. That is called angular nodes. This is along the x-axis. So this will be px, right? This is along the y-axis. So this will be called as py. And this is along the z-axis. If I draw it, this is along the z-axis. So that is why it is called as pz. Okay? Understood? That's why p orbital we draw it like this. This is px, then py, then pz. Right? Okay? So 1 is -1, 1 is 0, 1 is +1. As such, we can't say that -1 is px, 0 is px, +1 is px. They are not as defined, but it's like it is -1, 0 and 1, px, py, pz. There is no proper uh, uh, assignment that they have given. They have not assigned it properly, right? Now we have 3p, right? Do you want me to draw the graphs of 3p, guys? Do you want me to draw the graphs of 3p? I'll just, to make less effort, what I'll do, I'll just put the 3p graph here, right? Okay, let's draw the graph of 3p. How many angular nodes and radial nodes for 3p? How many angular nodes and radial nodes for 3p? This is 3p. Okay. N is equals to 3, L is equals to 1. So N minus L minus 1 is nothing but it is equals to 1. So there is one radial node. There is one radial node. Angular node is equals to L, that is equals to 1. So there is one radial node, there is one angular node as well. Okay, you will draw? Sure. Let's draw it. It is starting from the minima always. It is always starting from the minima. Right? Peaks are decreasing, then increasing. Right? I need to draw one radial node. Okay, so it will be like this, one and this. Here it will be like one radial node I need to draw, one, and that's it. Peak should decrease, no? Peak should decrease. So it will be like this. Starting from origin, it goes and peak decreases. Okay, here peaks are increasing. There is increment in the peaks, right? 1 and 2. And that's how you have only one radial node here. That is, this is the radial node, this is the radial node, this is the radial node. Initial and the final points are not the radial nodes. Now, if you want to see the diagrams here, right, you will see it over here. This is how it looks like. Now, visualize this thing, okay? One radial node. I think this is for the 5th time I am telling you this. In yesterday class also I explained it. Now also I am again explaining it. Radial and angular nodes are different. This will pass a plane, that is angular node. Here you will pass a plane, that is angular node. Here you will pass a plane, that is angular. But this is along the radius. This is along the radius, and that is one radial node. Because it will be like this, okay? It's like in the form of circle you will have. See, radius is simple. When in the form of circle you have missing electrons. When in the form of one plane you have missing electrons, that is angular plane. Okay. So here this is in the form of a circle. This is in the form of a circle. This is in the form of a circle. Right. And here you can see it is in the form of a plane. It is in the form of a plane. It is in the form of a plane. Okay. So one is your radial node, other is your angular node. What are the question we expect from this? I'll show you the question also. Simple graph they can ask you. They can ask you calculation of radial or angular nodes. I'll just show you that as well. Okay. Now this is for 3D, right? This is for 3D. You can see this over here. Acha, tell me for 3D, do you have angular nodes or not? If you want, let's draw it for 3D as well. And 3D is the last one that I'm drawing, okay? Because I know you will like be confused in the end. I know that. So as much as practice as I can do, I'm doing that. Whew. Okay. So it is 3D. Okay. 3D. N is 3. L is equals to 2. Radial node is equals to N minus L minus 1 and angular node is equals to N. Let's see who will answer this. Very good, future IITian. Ma'am, should I start first or complete classification of elements? Twinkle, see, as such, they don't have any relation. So, you can, it's solely your choice. The correct way is firstly structure of atom, then periodic classification. But because I'm doing it in the next class, so I would advise you take these both chapters simultaneously. Okay, beta. Now my throat has started to pain. Those who don't know, I have tonsils and I'm currently in a situation of surgery, which I don't want. So that's why I'm asking you, please answer because it is taking a lot of effort of this thing. And I know how difficult it is for me to even breathe right now. So if I ask you something, please answer it, right? Because I can't ask you same thing again and again. Yeah. Okay. Yes. Yes. Okay. So see this. Radial node is equals to n minus L minus 1, 3 minus 2 minus 1, that is 0. And angular node is 2. Okay? 2 angular nodes. See this here. Radial node is 0, so it's a very simple graph that you will draw here. It will always start from minima, peak. It starts from minima. It starts from minima. So it's not a big deal to draw its graph. It's very simple. Some students know they draw angular nodes here. They are like 1 node, 2 node, 3 node. We are drawing the graph for radial nodes, okay? So that's how you need to draw it. So there is no node. Angular node, I'll show you how to visualize that, okay? So angular node is actually over here, right? How to visualize angular nodes. Now I'll pass up two planes. Two angular node means two planes will be there, right? Is there any circle because of which there is no electron in a circle? Is there any circle where you can see there is no electron? No. There is a plane where you can see no electron. I'll show you. The planes are the plane over here, right? And the plane here. These are the planes because it's a double dumbbell shape. It will always be like this. It will be like this. So this plane and this plane is the area where you will find no electrons, and these are the two angular nodes. Okay. So whether you talk about dxy, dyz, dzx, or dx square minus y square, right? All will have two angular nodes. Okay. Now I asked you a question in the last class. Let me see who will answer me that. Okay. Let me see who will answer me that. Yes, everybody. Just give me a second. I got. Okay, everyone. Sure. Now let's see this. Acha. Now it's a very, very important concept that I'm going to teach you now. dxy, dyz, dzx, dz square and dx square minus y square, right? All will have two planes, but there is some difference here. Okay, if I'm drawing this here in 2D also, if it is dxy, it will be this and this. This will be x, this will be y. So here, this will be one plane, this will be one plane that is passing here, and this will be the other plane that is passing here, where you see no nodes, right? If it is dy square, let's say this is dxy, let's say this is dyz, right? So In between means this will be y and this will be z. Or you can see the opposite, this will be z, this will be y. Because between these two, you have this slope. Okay, between these two, you have to imagine it in 3D. Between these two, you have this slope. Okay, and this will go downwards and this will move like this, and here between this, you have. And here also, if you see, this is between this and this axis only. This is between this and this axis only. Okay, so that's how you have between the axis d orbital, right? So d, y, z. Here also you can see this is the plane which is passing, and this is the plane which is passing, which will have no electrons, right? So you can see this here as well. This is the plane and this is the plane. Okay, so again two planes here, right? And d, y, z also will have the two planes. So here this will be y and this will be z. Actually, this is x and this is y. Wait a minute. If I say this is z and this is y, right? dxy, dyz, dzx. This is z and this is x. Because this is between z and x. So this will be dzx. Okay, this also they have asked one question based on this. They will give you diagram which belongs to which thing. So you have to see in 2D that which two coordinates it is passing between, right? Now this also have, here it is clearly visible, right? Here it is clearly visible, right? That this is in one plane, this is the other plane. So these are the two simple planes, right? dx square minus y square. Again, it is a dx square minus dy square. X square minus y square. Here it is between the axes. How you will see? This is the axis, this is the axis. Can you see? Wait a minute. Can you see? It will be something here. This is also one of the axes. This is actually passing between the axes. I don't know how. This is actually passing between the axes. The axis was like this. This was one axis, this was second axis, and this was the third axis. And it is passing between this axis and this axis. So I'm just not drawing this one. Okay, to make this even more clear, I'll draw it here like this. This is the axis and this is the axis from where it is passing, right? This is it is passing, this is where it is passing. So it is along the axis. Along the axis, again it has two planes, where two planes means this is the one plane, this is the other plane, in which the probability of finding electrons is 0, right? Now this is extremely important. Okay, this is extremely important, that angular node visualized in the form of a cone. They can also ask you this. Okay, visualize in the form of a cone. Sure. Now I'll just show you how they are visualized in the form of a cone. So whenever you eat on any thela, on any street food, right? Have you ever eaten bhel puri on a street food? So when we eat bhel puri on a street food, they give us this kind of paper. Now Vedantu, like Vedantu, I need to hide it, right? So here you are having bhel puri here, right? And you're eating it. Or you, so if you're like, ma'am, we don't eat bhel puri from a street, ma'am. Okay, then you must have eaten cone, right? Ice cream cone. It looks like this, right? It looks like this, right? So this ice cream cone is nothing but angular plate, right? So dz square has a different kind of plane, that is angular plane. Okay. So here what you will see, it's very, very interesting that this will be the axis. Along the z-axis, it will have a lobe, right? And it will have some electron cloud over here. Now, if you see this as a cone, if you put this cone here, along this cone, you will have no electron density. Along this downwards cone, you will have no electron density. Along here and here and here and here, you will not have. You will have electron density here as well, and here as well. Okay, all of them will, like, means in an angle of this cone, you will have zero electron density. In between, you will have electron density. Outside also, you will have electron density. Let's say this is the axis, right? Here, you will not have electron density, but inside it, you will have electron density. Here also, you will have. But along this cone, you will not have electron density. Okay? Understood? Able to visualize this, right? That's how it works, right? I hope so. That is clear to everybody here, right? So a very important concept. They can ask you shapes of which of the following is same: dxy, dyz, dzx, dx square minus y square. They all have same shapes. dxy, yz and zx is between the axis. dx square minus y square is along the axis, and dz square has a different shape from all of them. Okay, understood? So these are spherical, s orbitals, dumbbell, p orbital, double dumbbell, d orbital, right? And this is the full visualization that I have shown you, everything we have done, px, py, pz, and this also we have done, how these are between the axis, how this is along this axis, right? And this, can you see this here? This is what I was telling you, that this white area is the electron, but along this cone, you will have zero electron density. Can you see this over here? Right? Okay. Now, let's see a question of JEE Advanced 2016. Let's see this question, guys. Let's see this. Okay. If you see this here, P is probability of finding electrons, the one is electron of hydrogen atom in a spherical shell. Now, firstly, understand this statement, okay? Understand the statement. You will find questions very easy. P is the probability finding the one s electron of hydrogen atom in a spherical shell of infinitesimal thickness dr at the distance from the nucleus. The volume of the shell is this. The quantitative sketch for dependence of P on R. P is probability of finding the electron. What was probability of finding the electron? Psi square or 4 pi r square dr psi square. This is the probability of finding the electron. That means you need to draw a graph between psi square versus r. This graph they are asking you to plot for 1s. JEE Advanced 2016, easily this can be asked in JEE Mains 2026. Okay? Now, very simple, tell me one thing. For 1s, s orbital, the graphs always starts from which phase? Maxima. Firstly, tell me one thing. For 1s, it is n minus l minus 1. So it is 1 minus 0 minus 1. So it is 0 nodes. Okay. And if you have seen this rule book here, for 1s orbital. From this rule book only I am picking up everything. For s orbital, right, it starts from maxima, right? For p and d orbital, it starts from minima, and for s orbital, for third graph, it starts from minima, right? So now that means this graph I need to start it from. Wait a minute, where it is? Wait a minute. Yes. Hmm. Wait. Yes. Okay. So if I need to draw a graph between psi square and r, I need to start it from maxima, right? If I start it from maxima, this and this is already eliminated. Then I need to have zero radial nodes, and that is possible only in case of C. Okay, that is possible only in case of C. Okay, understood? Yes, everybody, understood or not? Right? Now, next question is the wave function psi for 2s is given by which of the following? At r is equals to r naught, radial node is formed, r naught in terms of a naught is what? So a very simple question, right? They are saying wave function in 2s is given by this, radial node is formed. Radial node means this has to be equals to 0. That means 1 by 2 under root 2 pi, 1 by a naught, this 2 minus r by a naught, e raised power minus r by 2a. This all has to be equal to 0. So I want to find a relation where r is equals to r naught. So I'll try to put this equals to 0. If I put this equal, because any of the terms should be equals to 0, right? So I'll put this equals to 0. This will be 2 minus r by a naught. R is equals to r naught here. So it will become 2 is equals to r naught by a naught. So r naught is equals to 2a naught, and it is the fourth is the correct answer here, right? Okay, understood? Yes, everybody, clear or not? Option 4 is the correct answer here, right? Now we are moving towards because these kind of questions only they can ask you, right? Based on graph, they will ask you which of the following is the correct graph, this kind of question. And based on this calculation part, they can ask you put size equals to 0, put size square is equals to 0, and based on that, you will have the questions, right? More than this, they will not ask you, right? So now moving towards the electronic configuration, let's see what all you need to know, right? So first thing that you need to know is three rules, right? One by one, we will study that. So first is we need to understand how to fill what is exactly the energy of these orbitals, right? So for that, first thing is for a single electron species like hydrogen, what we do, the energy of an orbital depends only on the principal quantum number. That means as n increases, energy increases. That means for hydrogen or single electron system, you will have 1s, then it is 2s is equals to 2p, then you will have 3s is equals to 3p is equals to 3d, then you will have 4s is equals to 4p is equals to 4d is equals to 4f, right? So if n is same, energy is same. This is for single electron species, right? This is valid only for single electron species like hydrogen, right? But if we talk about multiple electron species, that is not valid there. For multiple electrons, what you need to study is the energy of orbital depends upon both n plus n. So it says that as n plus L increases, energy increases. If n plus L is same, then as n increases, energy increases. Right? Okay, this is a very, very, very important statement, right? Based on which simple questions they ask directly from the energy. Simple, very simple questions they can ask you directly from the energy. Okay. Now, applying this law, right? Yes. Applying this law, let's try to answer some questions here. Okay. The first kind of question we can ask you is write it in increasing order, right? So let's say they have given you 2p, 3p, 3s, 4d, uh, then 2d so does not exist, then 3d, right? Now you have to answer. Firstly, you would have to write the values of n plus n. Okay, you can also write 4s here. Write down the values of n plus n. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 0 is 3. 4 plus 2 is 5. 4 plus 2 is 6. 3 plus 2 is 5. 4 plus 0 is 4. Now, minimum value is 2p. Then these two have the same value. 2p and 3s. If n plus L value is same, see n plus L value is same for 2p and 3s. If n plus L value is same, you will have to see the value of n. Lower value of n is 2p, right? This has lower value of n as compared to this. So this will have less energy. So you can write 2p, then 3s. After this, you will have 4. It can be 3p or it can be 4s. When n plus L is same, less n is directly proportional to energy. So lower value of n corresponds to lower energy. Now between this we know that this n plus L is lower, so it will be 3d, then it will be 4d. Okay. So that's how they can ask you to arrange this in increasing order of energy based on n plus L rule, right? Now, based on this n plus L rule, after writing all of this, we have certain rules, right? Okay, I'll also tell you how to fill in these rules. So, 3 rules we have to fill the electronic configuration. First rule is Aufbau principle, then Hund's law, then Pauli exclusion. Aufbau principle is related to energy. It says that firstly, electron will be filled in the lower energy orbital. Let's say I have 1s and 2s. 1s have lower energy. So firstly, I will fill 1s. Then I will fill 2s. So lower energy orbital will be filled firstly. Lower energy subshell, not orbital, lower energy subshell will be filled firstly. Because if I say 2p, it has 3 orbital and all the 3 orbitals are degenerate. That also will say that which will have first filling, that also we'll talk about. But as of now, we are talking about subshells, right? Subshell which has lower energy, that will have electron filling first. So based on that, guys, a simple, you should know how does energy of orbitals, how does it work? Or you can say energy of subshell. Okay, let's see that. This is what is drawn in your NCERT. You can learn this as it is, but I don't remember this way. I'll tell you how I remember, okay? So I'll give you a simple trick of that. So write S, P, D, F. Okay. Now write 1, 2, 3, 4. Now what you have to do is, firstly 2 times S, then 2 times, you can say 2 times S, then 2 times PS, then 2 times DPS, then 2 times FDPS. That's how you need to write it. Okay. So, firstly I'll write 2 times S, 2 times S, 2 times PS, then I need to write DPS, DPS, then FDPS, FDPS. Okay. Now SS, PSPS, DPS, FDPS. Right? Now, S always starts from 1, so write 1, 2, then 3, then 4, then you have to write 5, then write 6, then write 7. P starts from 2, so write 2, 3, 4, 5, and 6. Right? Now, D starts from 3, so you have to write 3, 4, 5, and that's it. F starts from 4, so you have to write 4F here. And this is the order that you need to write down. Okay. Now, this is the increasing order of energy. Okay. This is the increasing order of energy what you have. And this is very important. Once you know this particular thing, electronic configuration will be very easy for you. Right? Very good, Abhijit. Do let me know in the comment section what is your trick. Right? Do let us know also, because maybe some students are out there will like your trick. Right? So, now Aufbau principle states that electrons will be filled in this order: 1s, then 2s, then 2p, then 3s, 3p, 4s, this. Right? Now, Pauli exclusion principle says that how many electrons you will have in one orbital. So he said that in one orbital you can only have 2 electrons, and 2 electrons should be of opposite spin. That means if I write this, if I draw 2 same or 2 same here, or if I draw it like this, if in an orbital if I draw 2 same and 1 different, all these are incorrect way of filling the electron. This is the correct way. Another way of saying this thing is that we have 4 quantum numbers, right? You can have principal, there is no 2 electrons in, this is a very important point, no 2 electrons in an atom will have all the same quantum numbers, right? If n is different, obviously it is different. If n and l are same, firstly if n is same, they belongs to same shell. N and l are same, that means they belong to same subshell. If ml is also same, that means it belongs to same orbital. If orbital is also same, room is also same, then they will have opposite spin. That means if first 3 quantum numbers are same for an electron, fourth will be different, right? Fourth will be different, plus half or minus half. Fourth is going to be different here, right? Okay, now maximum number of electrons in a subshell, this already I told you, electrons in a subshell. Maximum number of electrons in a shell, is 2n square. and in the subshell is 2 into 2l plus 2. Right? This we discussed in the last class. Right? Now, subshell are these possible number of orbitals. Here is S, we know that there is only one box. P, we know that here you have three boxes. D, we know that here you have five boxes. F, we know that you have seven boxes. 1, 2, 3, 4, 5, 6, and 7. Right? So that's why maximum number of electrons that you can fill here is, here it is 2 electrons, because in one orbital you can only have 2 electrons. So this will be all be multiplied by 2. You will have the answer, because in one orbital you will have 2 electrons. Okay? Understood? Right? Last is Hund's law. Hund's law. Anybody? Hund's law. What is Hund's law? Anybody? Hund's law is, we know that I told you one question. I asked you one question here that, okay, if you have P, this is P. 3 boxes, okay, ma'am, fine. D, 1, 2, 3, 4, 1, 2, 3, 4, 5, right? Now, they have same energy because same orbital belonging to same subshell, that will have same energy. So this px, py, pz, all the d orbitals as well, they will have the same energy. Now, how you should fill these electrons? How you should fill? Should it fill like 1, then 2, then 3, then 4th? How should you fill it? So Hund stated that if you have degenerate orbitals, firstly you will fill electrons singly filled. First you will singly fill all the orbitals, all the degenerate. Degenerate means, what do you mean by degenerate? Degenerate. Spellings may be wrong here. Degenerate. So it means that having same energy. Students, anyone don't write it in the comment section because Diksha is not so good with spellings, right? So I'm good with compounds, but I'm not good with spelling. So singly filled. So you will not, if you want to fill 3 electrons here, if you fill it 1, 2, 3, this is the wrong way of filling. How you will fill the electrons? It will be filled like this: 1, 2, 3, then 4th, then 5th, then 6th, 7th, 8th, 9th, and 10th. Okay, so if you want to fill 3 electrons, it will be filled like this, right? So first you have to fill all the orbitals with same energy, right? Okay. So now electronic configuration, right? Just give me a second. Now, what we will have, electronic configuration, right? So hydrogen, it is 1s1. Helium, it is what? Helium, it is what? Atomic number is 2, so it will be 1s2. Lithium, it is atomic number is 3, so it will be 1s2, 2s1. Carbon, it is atomic number is 6, so it will be 1s2, 2s2, 2p2. Right? In this 2p, how you will fill the electrons? In this 2p, you will fill electrons like this: 1 and then 2. This is 2p. Right? And this is your outermost. And whenever we will use these in chemical bonding, also we will use this. I will also draw the outermost. Outermost, you have to write. This is the outermost. This is the outermost. Here, this is the outermost. Okay. Sodium, it is 10, 11, sorry. 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. Right? This is the outermost that you have. Right? This is the outermost that you have. So you can say this is, yes. So this is 2s, this is 2p. And here you should have 1 also. Na? Sodium is 11. So beta, wrong, wrong, wrong. This is not the outermost for sodium. For sodium, it is 2s2, 2p6, 3s1. So this is the outermost, right? So how do you draw it? 3s, and here in 3s you will have only one electron. Okay. Now calcium is 20. So how do you fill the electrons for 20? 1 is 2, 2 is 2, 2p6. It becomes 10. Then 3 is 2, 12. Then 3p5. No. It should be 3p6. Then you have 4s1. In fact, 4s2. 6, 7, 8, 10, 12, 18, and 20. Now, this is the outermost that you have, 4s, right? If you draw for scandium, you can draw it like this. Scandium is 21, so it will be 1s2, 2s2, 2p6, 3s2. Now, ma'am, who will tell us this atomic number? That will be by practice. Okay, you need to do a lot of practice, and when you will go through different chapters of chemistry, eventually it will get into your head. My throat is now going. It's like I'm fractured from. It's like when you see some sports person, they get fracture on their body and they still have to, be in the field. So that's my case now. This is my weapon, right? From where I speak, from where I keep you engaged, and I feel now I feel like my energy is too slow. I'm too low right now. But you know what to do? I am doing my best as much as I can do, right? So, 10, 11, 12, this is 6, then this is 4s2, then this is 3d1. Okay, this is the outermost, right? Then there is zinc, that is 30. Okay, that's how you write it. This is the outermost. Now, do you also know that we can write it in the form of nearest noble gas? How? Here, helium, वैसे भी even if you write it like this, na, even if you write it like this, it won't matter. You can write it like helium 2s1. Because for 1s2 also you have to write that much. For helium also you have to write that much. So helium you will very rarely see written like this. But for this full thing, I can directly write it as neon. So we can directly write it neon. This can be directly neon, and this is 3s1. Neon means this whole means you have to write it in the form of nearest noble gas. Here this nearest noble gas is what? 10, 12, 18. So it can be written as argon 4s2. Again, this is argon 4s2 3d1. This is argon 4s2 3d10. Okay. Now let's see some exceptional electronic configuration. Okay. Let's see some exceptional electronic configuration. Yes. Okay. So if you want to see, this will also help you in 3D D block. 25 and I'll just write this 22, 23, 24, 25, right? I'm writing the electronic configurations of 3D. Okay. 26, 27, 27, 28, 29, and 30. So, if you see this here, argon I am not writing anywhere. Argon you assume. Okay? So, if you want me to write, I'll write. Argon. This is the atomic number 21 to 30 that you will use in 12th class. Coordination and DNF block is based on this only. 3-4 questions in exam will be done by this. Okay. Write 4s everywhere. 4s 3D. I wish I could just copy paste it. 3D. Okay. Here 2-1, write 2-1. 2-2, write 2-2. 2-3, write 2-3. 2-4, write 2-4. 2-5. Then 2-6. 2-6. 2-7. 2-8. 2-9. And 3-0 is not possible because 4s can only have 2 electrons. So write it 2 and this is 10. Now, this is nothing but Saktiv Karman. Piko Ni Puja. Okay? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Very important. Now, here what happens, this is exceptional. Here what will happen, here what you will see, here it was 4s2, it was 4s2 3d 4. But half-filled electronic configuration is very stable. So, one electron will jump here, it will become 5 and this will become 1. This is exceptional. Okay. Similarly, here you have copper. In copper, again, one electron will shift here for 10, and this will be 1. And that's how you will have your answer. Okay? Understood, everyone? Very good. Right? So, now the question is why these half-filled and fully filled are more stable, right? Why there are exceptional electronic configuration. So first thing is symmetry. So if you see this here, right? If you see this here, right? This is, and this is also D. This, if it is 1, 2, 3, 4, it is not that symmetrical. But if you see 1, 2, 3, 4, 5, from here also 1, from here also 1, from here also 2, from here also 2, here also third, here also third. This is more symmetrical. Same with fully filled also, it will be more stable. So half filled and fully filled are symmetrical. Then there is exchange energy. That means if you have symmetry, then one electron can easily exchange. But what if it does not have, what if it is D4? 1, 2, 3, 4. Now this electron cannot exchange itself here. Because according to Hund's rule, all the electrons should be firstly degenerate. So you can't fill it like this. You can't exchange energy here. It cannot exchange energy like this. Not possible. Not possible. Here, exchanges are possible. In fully filled also, exchanges are possible. That's the reason you have actual electronic configuration of chromium and copper is different. My throat is dead. Answer this question. Yes, guys. Okay, now Tell me. JEE 2021. Which of the following pairs outermost electronic configuration will be same? You have to write it. Okay, JEE 2021 question you have, right? Simple is I already told you these things here. Chromium, guys, it is 24. It is 4s1 3d5. Chromium positive will be nothing but 3d5. Manganese is 25. That is 4s2 3d5. Manganese 2 positive, you take out 2 electrons here, it will become 3d5. So yes, they have same outermost electronic configuration. So A is already correct. Okay. Ma'am, we can't take neon instead of argon. But then what's the point? Why we have written it here argon? Because I am very lazy, right? Scientists are lazy. Scientists are like, bro, we have other good things to do in life. We need to do research. We are not free to write this again and again. That's why they were like, okay, we will write it by the nearest noble gas. Okay, so that's why nearest noble gas is argon, right? Okay, so that's it for today. And guys, this is your homework. As you can see this on your screen, radial probability function, they are asking you value of this P. You have to find out. Okay, I'll just write it again. This is Z by A, 3 by 2, 2 minus P, this is e raised to power P by 2. Very simple. Put all of this equals to 0. Put all of this equals to 0, you will have your answer. You have to find the value of this P. Very simple. Okay, understood? Now, next is this question, JEE 2021. Take the screenshot. Certain orbital has no angular nodes, 2 radial nodes. Angular node 0 means L is equals to 0. Radial node 2 means N minus L minus 1 is equals to 2. Now solve these two things and find that L is 0 means it is definitely S. Now find out what will be the value of N, then from the following which will be the correct answer. Right? Take the screenshot. And that's it, guys. That's it for today. And yes, I would love to see your homeworks in the comment section. Take care, ma'am. What a hot, ma'am. Okay, complete your homework. Very good, beta. Very good, Ria. Awesome, awesome, awesome. Ujjwal, Siddesh, Abhijit, Premalata. Very good. Awesome. So proud of you guys. Right? And I want you guys to do it on your own. And guys, this is MBSAT. No fees is there to register yourself into this, right? You never know. Sometimes by luck you will, maybe. It's like, ma'am, I'm not prepared. How will I prepare in 1 month? See, I would advise you to firstly prepare and then be in the exam. But even if you're like, ma'am, I have so much other work to do, I can't prepare. It's okay. You have general knowledge, you know, like something you know about physics, chemistry, and maths, give this test. You never know. You will have good luck. And in that exam, you will start answering the questions and you can get 100% scholarship. You can get 2 crore rupees, worth 2 crore rupees prizes, including laptops, iPhones, drones, these things, right? So that you will get here. So I would advise all the students out there, you are in 9th, 10th, 11th, 12th, dropper, be in the scholarship, right? Then guys, here you have, we know that, yes, tomorrow will be the last day of freedom sale. Freedom sale is for Independence Day, right? Our India got freedom, so we are also freeing you from your fears, right? And because of this sale, this price is jumped to 1499, lowest till now, right? It is the lowest price of batch till now, right? Can you get that? You purchase 1499, I'll tell you, more than this it will cost you if you want to purchase one book. And in this batch, we are providing you modules, live classes, then mock tests, everything. Even if you want to purchase OMR sheet with some 10 mock tests, that will cost you more than this, right? It's a very good opportunity to purchase this course, because as this sale will like end, then again it will have its original price. Okay? Yes? Chal. Very good. Yes, you can definitely write MVSAT. Yes. Session finished fast, ma'am. Actually, this topic was supposed to be in one lecture, but as I told you, guys, I have tonsils. Like everyone has tonsils, but I have swollen tonsils right now, and it's been 20 days. I am on antibiotics, right? Even now, I'm taking antibiotics, and that's how I'm able to speak for you guys. So, after taking this 2 hour class, I'll have to do voice rest for next 12 hours. Only then I can speak in the next class, right? So, because of this, I'm not able to take long classes, but still, I think today, though, I took still 1.5 hour class. That's a great thing. And that's it. Now I'm putting my efforts even if I am not well. I'm not giving any excuses to you guys, right? In life, excuses you should not give for anything, right? Health is not fine, understand. Take a break, but then bounce back. I am not fine, even then. I'm trying to teach you as much as possible because I know that you have your exam, right? If I can take that much responsibility of you guys, even without taking a penny from you, you can do at least one thing. Do write down your homework because that makes me happy that what I am doing for you guys is worth it. When you guys don't respond, even I feel that I should take medical leave from job, right? Easily I can get medical leave for next 20 days. Not a big deal. Everyone is saying me to take rest, asking me to take rest. But still, I'm like, okay, it's okay if I teach for 1 hour in a day, it's fine. I can do that much for you guys, right? Now it's your time to show your love, to show your dedication because not that much time we have, right? This chapter we have completed structure of atom. Next, I'll start with periodic classification. I will try to complete it in 3 to 4 lectures, but because my health is not fine, so maybe it will take me 4 lectures, right? But what I want from you guys, be consistent. Okay? Be consistent. And like this video, share this video with your friends. That motivates me. Right? And do write down your comment. Do write down your homework. I wait for it. Right? Okay. Sure. Yes. Yes. Thank you so much, Vita. Thank you. Now I need voice rest. And tomorrow I'll see if I'm feeling better. Then I'll take class at 4 p.m. If I don't feel good, then I won't be able to take the class. Right? So I'll tell you in the Telegram channel. I'll inform you there. Right? Okay? Sure. Most probably I will be taking the class. Okay. Okay. Bye bye. Take care. See you all. Bye bye. Thank you, Sai, Premlatha, Future IT, and Siddesh. Thank you, Beta. Thank you. Sure. Okay. Bye bye.